All right, class. These are questions that came in that I wanted to make sure that we get to here. So this is 7.2 as we're starting to do hypothesis testing. So let's go for it here. This is a problem I've done already here. Just want to make sure that you can do it together here. So let's go for it here. So length of time in years it takes 32 former smokers to quit. Assume the population deviation is 6.5 years. We're looking at a 0.99 confidence interval. And is there enough evidence to reject the claim that the mean time it takes for smokers to quit permanently is 14 years? So let's go for it here. Here's our data right here. So first things first, before we get to the data, we want to make sure that we get our hypothesis claim here. And so as we look at here, the length of times for listed above, assume the population standard deviation is this, and here it is, evidence to reject the claim that the mean time it takes for smokers to quit smoking is 14 years. So that means the, as this is, say, stay as you are scenario here, the null hypothesis is the fact that mu is equal to 14, and that's actually the claim. The claim is that it is 14 years. So then the alternative hypothesis would be not equal to 14. And there it is. So that's the first order of business that needs to happen here. So the answer is B, at least on mine. You may have different numbers here. All right, then let's go on to the next one here. How do you look at and find the standardized test statistic? And I think I did it by calculator. I think that's the way I did it. I jumped to here. Let me see if I have what I still have here. Okay, so I went up here. Oh, there it is. I think that's it right there. And here's what I did on my calculator here. It's that little let's see, formula for the z-score. Right? Let me jump to one that looks like that here. So, right, it's z is equal to the average for your sample minus the average there. And it's going to be standard deviation divided by the number here. So this is going to be, let's find the standard deviation then. Let's jump it back over here. So we do have to get our StatCrunch operator here. StatCrunch, and I'm looking for the average of all these numbers right here. That's what I'm looking for. And pop it up real quickly here. Stat. In fact, let's do this one here. I think we should do this one with data. So it's z-score with data. Let's see what we'll get here. So the column that we're looking at is this one. In fact, standard deviation is 6.5. We can already enter that because we knew the standard deviation. And let's go with 14. That is null hypothesis. And I can't see behind here. I think it was a 90. No, it was a 99 confidence interval here. There it is. Our level. Compute that, and what I'm really looking for is 16.175. That's what I'm looking at right there. That's what I want right there. So now let me go for the z-score here. So jump back to my little PowerPoint presentation. This is going to be 16.175 minus 14 over standard deviation divided by the square root of 32. So this should be 2.175. This is just the subtraction on the top. And now I'm going to punch that into a calculator. And then we go from there. Alright, calculator punch in. And I did it earlier here. I get a 1.89. There's my number that I get. So I'm going to punch that in to this right here. Let me get out of this. And there it is. 1.89 is what I got. Okay, with that, then I'm going to have to go look at my chart, or just find the p-value here. This is the chart in back of the textbook here. I look for 1.89 on my normal distribution. Alright, and there's my little chart here. Let's see if I can read it here. So 1.89 is here, and then moving forward all the way to this category right here. And that's what I got, 0.9706. That's the area there. Remember, this is a this is the area inside here, right? So it's the one tail past the middle, right? And so what we want is we want the leftovers out of this. So if you subtract this from 1, let me maybe do that on the calculator here. I'm not sure if I had that done or not here. Let's see. Okay, 1 minus 0.9706. Enter there, and then we're going to double it because we have a two-tail test on our hands. So 0.0588, so really 0.059 is what we want. So now let's jump back to this one right here, and there it is. Here's your p-value. P-value is 0.059. Okay, and with that stated here, and so we are looking at 0.059, and we're comparing it to 0.01. So notice that's the significance level here for alpha here. So notice that is not, alpha is bigger, or you can say that, so the p-value is bigger, so therefore you were not able to get into the rejection region. So we failed to reject the null hypothesis D. Alright, moving on to 7.3, which is the next one. This is problem number 11. 11 on 7.3. So we have the Dean of the University estimates the average number of classroom hours that faculty spend in the classroom is 11 hours. As a member of the council, you want to test this claim, so a random sample of the number of classroom hours of 8. Ooh, hold on, significance level here, right? There's only 8 full-time faculty, less than 30. So this is the difference between 7.2 and 7.3. On 7.3, you have to use the t-table to get what you want because you're at less than 30. All right, so that's the only difference. I mean, that's the major difference there. So 0.05 is our alpha level here. Confidence levels. Let's see, can you reject the dean's claim? So let's go for it here. So first things first, which one are we going to select? We're not going to use less than or greater than, none of those. So A gets debunked, E is gone, C is gone, F is gone. So the only real difference is between A and D, B and D. And so remember, the claim is that the mu is actually 11 hours by the dean. And so we look over here, we say mu is 11 hours, that's the null hypothesis. So the alternative hypothesis is saying it's not 11, so D would be the correct answer here. As we jump to do actually the data, here's what you got to do in StatCrunch. You go to StatCrunch here, and we're going to try to find the p-value. And remember, the p-value is how much area you have, so it's this guy here, stat. And we're going to go to the t-stats right here. It's one sample, and we're going to pull it off of data as opposed to summary. So that's our column which we're getting it from. In fact, we can even put in the 11 hours already. And I forgot what the confidence interval was. I might as well do that here. Hold on one second here. It is, 0.05. There it is. Okay. So let me do that again real quickly here. All right, and jumping to StatCrunch again. There it is, stats, t-stats. They will automatically already think about how many numbers you have, right? So your degrees of freedom is going to be listed as well, and there it is. There's your p-value. So 0.2487. There's your p-value, and now the question is, and notice this guy corresponds to this one right here. So this guy corresponds to this one here. Alright, so looking at 0.249, we compare that to our level here, 0.05, and that is way too big. And so because of that, we fail to reject the null hypothesis because the p-value is greater than the significance level here. So that works. And then let's go with it here. Interpret the decision here. So we'll go back up here. This is 5%, right? So at the 5% significance level, there's really not enough information to reject the claim that the mean number of the classrooms full-time is 11.0. So it doesn't get into the rejection region, and that's what you're looking for. All right, just maybe a quick view of it here. Let me jump to maybe just a understanding of it here. So what you're looking at is you're looking at this right here. You're looking at, if my pen works, all right, here's your normal curve, right? And we're saying if this is true, we're looking at this right here at a 5%. So that means 2.5% is going to be here, and 2.5% is going to be here. This is the rejection region. So altogether, that's kind of what we're looking at though. Altogether, you have 5% that's left in the rejection region. Okay, when we did our work, we got this number, so almost 25%. So really what's happening here for our statistical data that we did for our little sample is we had this much. Notice our values were not, here's 25% of the data right here. Maybe a little further out, but anyways, there it is. So our values are not in the rejection region. Hopefully that kind of gave you at least a little bit of an illustration there. So it's really talking about area. How much area do you have left in the rejection region? If that p-value was smaller than 0.05, then that means that we would be over here, right? But we're not, so we're inside the region, so we can't reject it yet. All right, the next one up for grabs is this one right here. So 7.5 now deals with irregular or get over here, normally distributed sets. And so we look at chi-squared. Is that what we're looking at? The standardized test statistic being chi-squared here allows us to reject the null hypothesis here. And really, once you get the left and the right values correct, it's just about comparing them. That's about it. So these 4 problems should go very, very quickly here. So this is 7.5, sorry, question number 8. 7.5, question number 8. Let's go with it. I did the first one already here. So 26.298, you're looking at the right-hand side then, and you're comparing it to 26.296. Well, 0.298 is going to be in the rejection region, so we reject the null hypothesis because the standard is in the rejection region. All right, 26.294 compared to 296. Now it's just a little bit before the rejection region, so it almost did, but not quite. So at this point, we do not reject the null hypothesis because the standard is not in the rejection region. There it is. Do not reject because it's not in the rejection region. Let's check our answer. Oh yeah, all right. Okay, so now 7.960. Now notice this one's a lower number, so therefore you're going to be looking at the left side. So 7.962 compared to 960, so that means 60 is going to be on the left side of that. It doesn't, so it is in the rejection region. So yes, we're going to reject the null hypothesis because it is in the rejection region. And last one, 7.964. Think of the number line, right? Think of a number line in decimals here. So 7.962 and 7.964. Now it's actually on the right-hand side of that line. So therefore, we do not reject the null hypothesis because it is not in the rejection region. Check our answer. We are good. Okay, and then I think the other one was to jump to number 12. Oh, let's see, I'm sorry. Yeah, number 12 was the other question. And so let's go for it here. So claims that the standard deviation of the waiting times experienced by patients minor is no more than 0.7 minutes. So no more than, so that means it's less than or equal to is the claim. And the alternative claim is that it is more. So we got this one on our hands. Okay, and then let's find the critical values here. All right, let's look at our statistic here. Let's see, there are random of 27 waiting times. So therefore, we're going to go to 26 for the degrees of freedom. And we have 20, okay, and then 0.7 two tails, there it is, and we're here. So this is 0.95 coming down. So I have a 38.885. That's my region here. Alright, next one here. So identify the regions. Choose carefully here. So let's see. The claim is the fact that it's less than 0.7 or equal to, right? And then the alternative hypothesis can be greater than. So that's a two-tail. Obviously, it's going to be a one-tail here. So one tail, and also looks like it's a difference between B and D right there. And remember the claim. The claim is that it is no more than 0.7, but then on our samples, what we get is we get a 1.1 minute. So I'm going to go with this one here because it is, let me just see if we get numbers here. No. So 0.7 would be here, 1, so we're looking at our right test here. So let's take this one, and still nice work. All right. Find the standardized test statistics now for us. So now what we got to do is we got to do a little formula here. Should we write down the formula real quick here? No, let's go to here. Yeah, that's my little extra sheet here. Formula that we need to use is, there it is, n minus 1. We have s squared on our hands over variance squared. Let's punch in those numbers. Let's see what we get for our value. Alright, and then let's plug in the values here. So we had, let me go back real quick. I think we had 27, right? 27. So degrees of freedom would be 26. The claim is 0.7, and what we got is 1.1. Okay, let's jump to this one here. So 26 times, we got was 1.1. I gotta go past that, divided by 0.7 squared, and enter. Let's see what we got here. So I have a 64.20. 64.204. All right, we got that going. All right, and finally, here it is. Let's decide what we got here. And so what we'll do is we will reject the null set, because what we needed to reject is 38. That's the critical value right over here, but our answer got 64. It's way over here. And so we reject HO because the statistic is inside the rejection region. Okay, hopefully that was good for you guys. To finish up here, whoa, okay, hold on. One more question here. All parts showing now. Okay, is there enough evidence to reject the spokesman's claim at the 5%? And so at that point, since the null hypothesis was rejected, there is enough evidence to reject the spokesman's claim. All right, excellent work. Hopefully that helped you up in Chapter 7 homework.